Hello guys, in this video we're gonna look at how you can build this Vellum looping simulation using Houdini. In first chapter, which is this one, we're gonna build this setup first of all, and then in the second chapter we're gonna look at how you can render out this image using Redshift with the Houdini. So we're gonna build everything from scratch. I think it's gonna be useful for a lot of people, how you can deal with the color profiles and how you can render out clean PNG sequence from Houdini using Redshift. We're going to start off by creating a geonode, dive inside and create the box node. In this box node, my parameters were like this. So I created this long ass box. Then I UV unwrap this box. So by UV unwrapping, you get this nice quads here. Next up, I did scatter. So I scattered around 100 points. So I usually set this to a random seed. In my case, it was 123. And then we use Voronoi fracture to fracture this geometry. So we get something like this. If you use a exploded view, you can see we get this chunks like that. You can try out different variations. You can, for example, turn off the relax iterations. You will get more uneven chunks, or you can use something like saw offset in order to create a volume of our object, and then you can scatter inside of the object. But in my case, I just use this simple setup here. So this is our basic geometry. Next step would be is to create the geometry. So to basically spherify those chunks. For that we're gonna use the for each connected piece. It will give every chunk a unique class attribute, which you can preview of course in the primitive attributes here. By the way, I'm using the Alt-S shortcut for this spreadsheet here, and then we're gonna run a for each loop over those chunks so we can do something to each of those chunks. And first of all, we're gonna remesh this. Okay, so the remesh, the parameters that I find working is this one, so 0.0175. This is good. If you look at the output here, we get one problem here because we're remeshing this, we get this weird artifacts here. And the fix that I found is you can actually run another loop over each of those polygons, right? So we select here primitives, which is our polygons in this case, and then we run a for loop. And after you remesh this like this, everything is good. But another problem after the remesh is that it gives us a double points here. So basically it unconnects our geometry. For that we're gonna use a fuse node here, and then the parameters that I found is 100 or 0.0025. Yeah, so this will fix our problem. And then also what I did was I generated the UVs for insides, so for those pieces, and of course our Voronoi fracture gives us the inside group here, so we can use this group to calculate UVs just on the insides, because we don't want to mess those UVs. Okay, so we don't want to mess, wait a minute, what's happening here? I guess it's bugging. No, it's not. Okay, this one, yeah, we don't want to mess these UVs. We want to create the new ones like this. So yeah, it's fine. It's just strange viewport here. As you can see, it's fine. Okay, so this is done. Now we want to turn this into the sphere. We're going to use extract centroid here, and we're going to run this over detail. It will put a point inside of the centroid, there is a different ways you can get this point. You can use like a get bbox center and stuff like that, but I like to use just nodes here. And then also we're gonna use bounding box node bound, and then set here the sphere. This is quite one of my favorite nodes to use because it gives a lot of nice attributes, like it can give you full transformation matrix, stuff like that. But in my case, I'm gonna use just the radii here, and as you can see, it gives the size, the diameter, I guess, or I mean, it just gives you the size of this sphere. Okay, so we're gonna have to copy this back to our point, because later on we're gonna copy a sphere to this point. So let's call this copy radii attribute, and then the code of course is quite simple. At pscale equals detail, so because the radii attribute is living on the detail, so we're gonna use input number 1, and then the attribute is called radii, and then the index of this attribute is 0 because it's the same on each axis. And I want to divide this by a quarter. Okay, and then let's create the copy 2 points, and I'm gonna use this as a target copies, and then create a sphere node here. The sphere node I set to polygon, and then the frequency is 6, and as you can see, it creates a sphere around our chunk. And if we try to blend shape this, it will not work because we get totally different topologies here. And what I found out is you can just use the ray node, get our chunk, and then just project. So basically project original mesh to sphere. Okay, select here the minimum distance. I'm gonna untick show guide geometry, and then as you can see here, we get this sphere. And then if you try to use a blend shape, it will work just fine. And of course the viewport is kinda sus because we have to just recalculate the normals, and here we are. I also used a attribute blur because I wanted to a little bit smoothen out the topology here. And what I did as well is, if you look at this, the UVs, this is not what we're gonna use for rendering, because if you put the texture on this type of UVs, it's gonna look terrible. So what we're gonna do is we're gonna just create simple UV project node. UV project. We can set this to default, so I'm gonna just press Ctrl and middle mouse button. Okay, I'm gonna leave this to 90, and then here I'm just gonna select the polar UVs, and as you can see, it somewhat creates nice UVs. Of course here we got pinching, but that's not a big deal. It's still a lot better than what we have had before. And also here we have to somehow select the center of this object, because each of those chunks will have different positions, and if positions are messed up, as you can see, you get this weird result. So we're gonna just use simple expression, which will give a position of the centroid of the incoming object. So we're gonna use centroid, and then we're gonna use a input number 0, which is this incoming geometry, right? And I'm gonna use dx, which is x-axis, y-axis, and then the z-axis. All right, so we link this up, and then what we have to do is we have to copy this position back to this geometry. And also the thing is that this UV attribute would be called not UV but UV2, because when we want to maintain these UVs and we want to also maintain these UVs. Okay, so let's create the rest position node, and with this node you can just copy this as a rest, and then we're gonna call this for example rest sphere. So we're gonna just store this into the another attribute called rest sphere. And also what we're gonna do is we're gonna use attribute copy, and also copy the second UVs that we did. So vertices, and then UV2. So now we have all the attributes, UVs that we need. And there is one last thing we need to do is we need to create some sort of the mask. We're going to use this mask to transition between spheres, and then there's chunks. So let's call this height mask, for example. And then in this simple node setup, we're going to take the bounding box of input 1, which is our chunk, and then we're going to extract the Y component, which is this just simple mask here, and I want to output this as a height mask. So that's pretty much it. So if you let it think a little bit, you can see we get this thing. There is problems with some of those chunks, but this is just a normal problems. We can fix this by setting correct normals, and as you can see, just fine. So if you want to visualize your spheres, you can use attribute swap. All right, attribute swap, and then you can swap the rest sphere to the position. This is weird, of course, because we're going to use normals. We're going to recalculate them, and as you can see, here is your spheres, just like that. And the topology is quite nice. The Vellum will have no problem with this topology. Next thing what we'll do is we're going to create the mask, and then we're going to transition between spheres, between chunks to spheres. For that, first of all, I'm going to have to sort those primitives by Y. This is going to be used in the masking section. We're going to get to that. And then let's attribute delete our class. We don't need this anymore. And then let's create a new attribute, but this time on the points, and this also class. And those two nodes are connected because we're gonna sort them by Y. So basically, if you visualize this like this, class, and then if you set this to the markers here, as you can see, the objects here are position sorted, that for example the bottom chunk is 0, and if you don't do this, this is going to be random. So we have to sort them first, then give a connectivity, but we want to have this on points, of course, and this one is sort on Y. Okay, and now I'm gonna also quickly fix problem with the UVs. So if you visualize this UVs, this is our first UV, but if you press space 5 in the UV view mode, you can set this to UV2, and then as you can see, if we visualize this like this, right, those are a little bit stretched, so we can use UV transform here. UV transform, we wanna transform the second UVs, and I'm just gonna increase the scale on the x-axis, and now they are not stretched like this. So this is our preparation, and let's call this out static mesh. Let's now create a mask attribute, and of course I'm gonna use my own node grow attribute here. If you don't know what is this, if you go to my YouTube here, you can see that I have this video here, and this asset is totally free. It's really good. It saves you a ton of time, and it's really like customizable, stuff like that. So I'm going to show you why this node is really powerful and why you should use this every time when you are creating some sort of a mask. So in my case, what I did was we have to set the ranging. So my ranging was from frame 1 to 125. And if you press this button here, you can set some sort of a effector, and you can press this button to visualize the mask. And as you can see, this mask is just on the bounding box and it just goes through X. Okay, so we created previously this class attribute, and this class attribute goes from like 0 to like how many chunks we have. In this case, we have 99 or 100 chunks basically, because it starts from 0. And then I'm going to use attribute, and by default you can't access integer, but you can just say class. And if you look, this is what you will get. As you can see, it's totally working and it's quite nice. And then what you have to do also is create the attribute, and we have to use our height mask that we created here. You're gonna see nothing is changed because the class attribute is having a lot of effect on our growing, because it's like goes till the 99. So we have to just adjust the influence radius here, and as you can see, now we get this really nice mask, and you just don't have to do anything. It just works out of the box. You just have to set your attributes how you like them to grow, stuff like that. So I'm gonna lower down the height mask as well, and I'll have this nice transition, and I'll lower down the width to 0.1 here. This is our mask, but we also want to transform them to spheres right now, because we want to use a rest plant later on in the vellum. So let's call this to spheres, and then inside it's quite a simple setup. And what you have to do is you have to get the attribute that you stored here, right? So store rest sphere, let's call this, and then let's get rest sphere, it was called. And if you pipe this directly to the position, as you can see, we get our spheres here, but we want to mix them, of course. So we're going to use the mix. We're going to mix between the original position and then the sphere position. And also, of course, we're going to get our mask that grow attribute is outputting. So let's call this mask. Okay, and let's look what it gives us. And as you can see, this is nicely transforming, but of course we have to update also normals, and there you go. As you can see, it's quite nice. So this is going to be our rest blend, so we're gonna reference to this later on. But next up is of course our vellum simulation. To set up the vellum simulation, first thing that we'll have to do is use our original static mesh. The problem with this, of course, is that those chunks here are like penetrating each other, and the vellum doesn't like that, because vellum in the initial frame, it needs to have a non-intersecting mesh. So what I did was I just picked those pieces a little bit to give them a little bit of a breathing room. You don't want to overdo this, of course. And then we're going to use a vellum configure balloon. Okay, so my setting is that I lowered down the edge length scale. This is basically the thickness of the cloth layer, right? So I don't want them to intersect here. So I lowered this down. And then the parameters, the stiffness of the stretch constraint is by default. I upped the bend a little bit, and that was pretty much it. In the pressure constraints, what I did was I set the stiffness to 10 and the multiplier to a 10,000. So I want them to be more balloon-like, so less, to have a less stretchness, bendness, stuff like that. So next up is Vellum Solver, of course. I want to start from frame 1, of course. In this, I turn down the forces and I use the wind -1. So I want newly born, let's say newly born spheres to go down. If you press play here, what will happen is that everything is going to be like this. So it's slowly moving down. But of course, we don't want to have pieces that are not transforming to sphere to be moving, right? So what we have to do is we have to first of all copy our mask back to the vellum geometry, because vellum is not gonna reference that. That's all. In order to do that, we can use simple geometry wrangle here. Let's call this add update mask, and then in here set the input 2 to sup, and I'm gonna just copy and paste the rest plane here. Code is very simple. Mask equals point. The input is 1, which is the second one, of course, because it starts from the 0, and then it's a mask. And then of course our point numbers are the same, so we're gonna just use @ptnum. And as you can see, just like that, we already have the visualization here. And if we just press play, as you can see, our mask is growing, and that's exactly what we need. We're gonna create another geometry wrangle here. This is going to be used to activate our pieces, and the code is quite simple as well. So if mask is bigger than 0.1, so if you have a little bit of growing on those chunks, we're gonna set the stopped attribute. The stopped attribute is basically Vellum internally understands this attribute. If it sets to 0, it means that the piece is free to move, to rotate, to change position. But if it's not set to 0, then if it sets to, for example, 1, piece can't translate. If it's set to 2, piece can't rotate. But if it's set to 3, piece neither can rotate or translate. So we're gonna set like this. So if the mask is bigger than 0.1, it's free to move. So it's basically free to move. If it's not, it stays the same. Okay, let's watch. And as you can see, these bigger chunks don't move here. Only those on the bottom starts to like, and we have to wait a little bit, but you can see it's starting to like go down here, as you can see. But those staying the same. So this is exactly what we want. And then of course the main thing here is vellum rest blend here. We want to update the rest blend each frame. What basically rest blend does, it updates these set of constraints that we have here each frame. So the constraints for these type of chunks would be different for constraint to these spheres, right? And if we try to like change the position in vellum, it will not work. But if you try to set it with the rest plane, it will work, because the vellum would try to match constraints of the sphere to our chunks, and it will have correct behavior of a sphere and not of this like weird chunk that we have. And of course we want to update this to the sup here. So again, Ctrl C, Ctrl V, and everything else is by default. And what I also did was I set the pop wind here, basically just a simple noise. And here is the important part. I had a loop of 140 frames, right? And what I want is when nearly to the end, right? Near the end, I want all of my pieces to go down as quickly as possible because I want to get them out of the frame here. So I use the expression here. I just use 1.y. I multiply this by simple expression again. So I want to fit the frame. Okay. And then I want to fit this from 115 to 140. And I just want to multiply this from 0. So basically on the frame 150 it will equal to 0 multiplied. On the frame 140 it will equal to 1, and then the basic velocity is -3. And also what I want is I want a little bit of randomness between those chunks, so I use @random, and I used our set it to points class attribute here. And what I want, of course, I don't want to have a lot of effects, so I'm going to put this into semicolons and I'll multiply this to 25.25 because I want to have them less effect. So this is our Vellum simulation. What else we need is we need to use a clean node to get rid of all of those attributes. We don't want to save them basically. So I'm going to untick those and I'm tick remove attributes and remove groups. What I want to keep is I want to keep the mask here. Let's use a file cache now. Let's set, I don't know, somewhere here. Let's save this and then set this cache morphing spheres, for example. Of course, I want to load from disk and I want to save a little bit more than my looping range. So I'm going to set this 175, for example, and let's cache them. And this is the result that we got from this. And as you can see, it's quite nice. So let's turn on the visualization and this is what you get. And as you can see at the end, it just start to go down. And this is exactly what we need basically. So we want to blend in, of course, with this static mesh. So we're not going to use this thing because here we have these holes and we don't want them, of course. So we're going to attribute copy to the original static mesh the mask that we created here. So let's just copy this and let's just name this copy mask. I'm going to use attribute Vop, and of course nothing hard here. It's just blending the positions. And what we need here is we want to import attribute from the second input. So I'm going to use import attribute, and if you look, this is what we'll have. And then we want to mix this, the same thing that we did before basically. And then we're going to use bind to get our mask that we copied, and this is what we have. And the thing is here we have to add the normal, and then the settings is like that. So basically we compute normals, and this is what you get. It's quite nice. It's transforming from this, and that's it. That's the basically our morphing spheres. Morphing spheres. And then next thing what we're gonna do is we're gonna create the looping of this thing. In order to create a loop, what we have to do is, of course, we have to set up some sort of a camera. And then what I did was here, if we look at this is our camera. So let's view this camera and let's set, first of all, I'm gonna up this a little bit and I'm gonna just go further. Let's set this to square, and I used a null to animate this camera. So this is transform. What I did was here, I animated this null. First of all, I set the rotation to be like this, and also in my camera what I did was I set correct aperture and focal length that I want. And in terms of animation, It's quite simple here. So in the transform node, I set the keyframe on the first frame and then keyframe on the 125 frame, and then I just up this to go about like 2 units, and this is what I had. So it's just going up, and then of course the easing I want to be linear. So if you set, basically you can set the keyframe with the alt node, just what I did, and then if you press the shift left mouse button, you can get this animation editor, and if you press Ctrl A and here you choose to use a linear, you want to set this easing to be linear, so it goes up, and that's it. And here, as you can see this weird behavior in the camera. What you have to do is you just have to up the near clipping here, and it will fix this problem. So this is the camera. I did nothing else here, but next step we're gonna do is we're gonna work with the setup itself. So we're gonna have another box like this to push our balloons, and then our original box, and like this we're gonna create the looping behavior. So what we have to do is just copy our box, so it's going to be the same size, positions and everything, and then we're gonna just create a transform here. So let's create transform. Let's just colorize this to the, like for example, red, right? And then with this transform, I'm gonna animate this from frame 100. Basically in the frame 100 I want this to be at 4. So basically we have a camera that goes to 2, and this is going to be living at 4 here in terms of Y position here. So I'm gonna set the keyframe, and then in frame, the last frame, I'm gonna set another keyframe. I'm gonna just put it down to like 2 units. And if you look at the like the first frame here and then the last frame with this node, as you can see, it's exactly the same. So this way we're going to create this loop, and then the easing I'm going to use with this node is I'm going to just click shift, and I'm going to just adjust the easing how I want this to be. So something like this, and if you look, bam, and this will create a loop for our animation. But the thing is that we want to have this box to be like to be interacting with our spheres, because now it's not. We didn't set any collision, anything here. So if you display this, as you can see, nothing is happening. So we're gonna use this just as a collider. So we're gonna have to use VDB collider, and then with this node, this is new node in Houdini 20.5, and this is one of my favorite nodes. So to be honest, this is so good. I always use this with Vellum because it gives a lot better collisions with the Vellum balloons here. So I'm gonna set the friction. We don't want any of that, and this is basically the settings for this. So let's connect this to the Vellum collision geometry, and that's pretty much it. So we don't have to do anything else. So let's recache this Vellum. So after recaching our Vellum, we get a result like this. So it goes up, and then this is like going down. I mean, it looks pretty good here. So what we have to do now is let's go back to our morphing spheres. And what I did here was I wanted to have this last standing here balloons to be still in the frame in the first input. So I want to give a illusion that this is not the loop. So I don't want them to go like all the way down. I just want them to still stay in the frame, because this will sell the effect a little bit more. So let's create a time shift, and all we have to do is just offset this to a last frame here. And then the thing is, because our camera is moving, we have to compensate for the camera, right? because the camera is moving up a little bit. So the compensate camera is compensate for camera, right? Let's set this to 2, -2 actually. And then as you can see at the first frame, basically this is what we had with our camera, right, in the first frame. But we want it to be a little bit down because we are changing this to like 2. Here we are changing, of course, the position to 2. So when we just compensate for this, this is what we get. And what I did else was I just time shifted this and then just clamped this to the last, because I had some problems with Redshift. When our geometry just disappears, Redshift didn't like that. So I just set this to end frame to 25. So basically when it goes out of frame, I just freeze it so it doesn't just disappear, because our cache is only like 175 frames. We start with the spheres already, they go down, and then the new ones are born, I guess. So if we cache our animation right now, there is of course one problem. We still don't have the second box coming in. So like this, you don't have the second box coming in here. So that's the problem. So we're gonna fix this. But the problem is with this is that we don't want to just like copy this box here, because if we use this in the shader, of course this is not gonna have all the UVs, all the correct like stuff that we had. Also the mask is not gonna be equal to anything. So what we have to do is we have to just copy these transformations back to our static mesh. And why we created this simple box in the first place is to have a more lighter collision with this vellum. So let's bring in the static mesh and I'm going to create attribute triangle. Of course, the simplest solution would be just to copy and paste this node or like create a reference copy, but I'm a lazy person, so I'm gonna just output the transform here, and then I'm gonna, of course, just copy this transform back to this mesh. So for xform, so I'm gonna create a 4x4 transformation matrix, and I'm gonna copy this back to our original mesh. So this is just copy, and I'm going to use node called transform by attribute, and as you can see now we have the same animation that we have with this node. And then of course we're gonna copy the recompute normals here. And what else we need to do is we need to create a just a dummy attribute mask, and it should be equal to 0, because this is not going to have any affecting masks here. So let's just copy this back and remove this line here. So this is it. Let's just bring this up here and let's create preview. And after the preview is done, this is what we have. Bam. And then it just keeps looping itself, which is pretty cool. So in this second chapter of this video, of this series, we're gonna look at the rendering side of what I wanted to do. I want to build whole rendering setup from scratch, so to set up shader from scratch and to render out to disk using Redshift with Houdini. What I found out was there is not much tutorials covering this, so that's why I wanted to create like second chapter to like build this whole rendering stuff from scratch. It's not gonna be hard, it's just like simple render, but still I think it's going to be useful for a lot of people. So stay tuned for the second chapter. If it's out, I'm gonna link this down below